Dear students, in last class we have discussed about the introduction of soft computing. So in the previous two classes we did the context setting of the subject. As I was discussing in the last class about the context setting, why context setting is important. It gives us the complete picture why we are going to study this subject, what are the industrial application of the subject, what all topics will be covered in this particular subject which we are going to study in this current semester, and what is expected outcome is there from the student. That is also very, very important. When I say expected outcome as a teacher, what I expect from you once you've gone through the complete cycle has completed of this subject. So what we are expecting from you? We are expecting that at least you understand the concept of artificial neural network, soft computing, and genetic algorithms. Not only the basic concept, you will be able to write some program, do some simulation about the artificial intelligence, genetic algorithms, and application of the soft computing in totality. So in today's lecture, we will discuss the introduction to artificial neural network. So I want to go back when you were studying in the class 10th. So I hope all of you have gone through the biology, and little bit introduction has been given about the human brains also. So let me say to all of you, the artificial neural network, the word is very, very significant over here. Why we are using the word artificial and neural, we all know that is a biological neural network is there in our brain. So why we are calling it artificial neural network? This complete topic of artificial neural network, deep neural network, has been inspired from the biology itself. So to understand the subject well, how the mathematical simulation has been done, we have to really understand the little bit, or we have to do the refreshing of our concept of biology also. In today's lecture, the flow will be like this. First of all, we will try to again rebrush our concept about the biological neurons, and we will establish the analogy between the biological neurons, then the artificial neural network. Artificial neuron. When I say artificial neuron, it means what? We will try to build a model, mathematical model, through which we can simulate a basic unit of our brain that is called neuron. So let us start the lecture formally. These are the topics which we are going to discuss today. Biological inspiration of neural network, brain computer, biological neurons, ANN is a brain computer, and artificial neural networks and neurons. Alright guys. So biological inspiration of neural network. See, if we see the human being and all species in the universe, they have a IQ. They can take their self decisions. What you will when you see your device like your mobile phone, your desktop, or any other computing device, they don't have a IQ. Whatever the program you are writing on this one, whatever instruction you are passing to the machine will take the decision accordingly. It cannot take decision by itself, and it cannot learn from the environment also. So now right now in the complete all over the world, this kind of research are going on. We want to make machine more intelligent. Day-to-day life, they can take the decisions like human beings are taking, like other animals are taking. For example, if you are going to cross a road, then you have a IQ that you see the left and right. When there is a vehicles are not coming, then only you pass to the road. But let's think about the machine. The machine don't have a IQ. If the machine is trained like a human being and be fed the instruction like this, it can emulate or it can simulate from the environment, then only you are passing the roads. So that kind of a structure we will learn that. So biological inspiration of neural networks. Animals are able to react adaptively to change in their external and internal environment. That's very, very important. So our task is to develop a mathematical model, develop a computing model, which can adopt the knowledge from the environment, which can learn from the knowledge from the environment, external environment. And when some new situations are arising, it can take the decision on the basis of the knowledge which the system has gathered from the environment. That is a biological inspiration. An appropriate model simulation of nervous system should be able to produce similar response and behavior in artificial system. That sentence makes the this is a complete statement about the subject. So here what we are going to do? We are going to design a mathematical model which can simulate so that the system can behave like a human being. All right. I hope you understand. So principles of brain processing. This will give you the complete picture of our human brain. If you think about the human brain, see what human brain can do. Primarily human brain can do three big things. Massive parallelism. What is the meaning of massive parallelism? See, all of you have observed that in day-to-day life. We all observe in day-to-day life. Our human brain is not only trained to do one particular job at a time. We can do multitasking at a time. We can, while we are eating, we are watching the TV also, we are listening to music also, and we are attending the phone calls also. If I am attending the phone call, so I am writing also. You can also write. So how we are, let us think on this point, how we are doing it. If we are passing instruction to the computer to write something, it will write only. If we pass the machine the instruction to write and to listen, it will do these two kind of a task. But the human brain is trained to automatically behave for the multiple tasking, to do the multiple tasks at a time. So the massive parallelism, human brain is perfect example for multitasking, massive parallelism. It can do multiple tasks at a time. It can take multiple decisions at a time. Next, connectionism. My dear students, in the next couple of slides, we will discuss that. Even nobody can say that how many neurons, basic biological units are there in our brain. It is said that the 10 billion of neurons are there in our mind. You can assume that a small neuron works like a small computing unit, like a small CPU. It will not be unfair if I call a neuron as a CPU. So the neuron work like a CPU. So 10 billion of neuron is there. So and those all neurons are interconnected. It is assumed that more than 60 trillion interconnections are there. That is why connectionism behavior is there in human brain. Associated distributed memory. It is said that as such there is no secondary memories like a structure is in a human brain. So how the brain memorize, that is also a very, very important thing. First, massive parallelism we have discussed. Second, voluminous connectionism. Then associated distributed memory. What is the meaning of here associative distributed memory? The meaning is simple. There is no concept of secondary memory in brain. So then how brain remembers? When the neurons are interconnected, the strength of that connection established about the memorization. So these are the basic characteristics of human brain process. That is how human brain processes about the instructions. So now what is our task? We will develop a mathematical model which have all these three capabilities. It can do massive parallel work, different connections has been established between the mathematical models, and it have a capability of acquiring the knowledge also. All right. I hope the concept is clear. Okay guys, so now this slide will give you the more elaboration about what I was telling you about the neurons in a human brain, the interconnection between the neurons. The brain computer, what is it? Can we say the human brain is a computer? If you try to establish the analogy between the desktop or laptop and the human brain, you will find that only difference is that the human brain, we can also give the knowledge to the human brain also. We can give the knowledge to the computer also. But the present machine is not having the three qualities which we discussed in the previous slide. As I was telling you, more than 10 billions of neurons. This is a snapshot of a particular neuron. It probably looks like it. And the human brain, we all know that. And these all neurons, 10 billions of neurons are interconnected to each other. So those interconnections make somewhere 60 trillion of total in total connections. So that is huge structure is there. So it is almost impossible to completely emulate or simulate the human brain. So now what we are going to do? We are not going here to completely simulate the human behavior. What we will do, we will find out a problem, and the problem for which we are going to we are trying to find out a solution. And for that particular problem only, we will build a neural network. So the small set of neurons are required, and the interconnection between those neurons are required. The topology or structure, we will discuss that, and all those things will depend on the problem only. All right? Okay. So this is how, let us develop more understanding about the biological neurons also. That is also very, very important. So I think you will be clear when you are studying in the 10th class. So the structure of biological neurons has been narrated by your teacher also in classroom. So let us refresh again. The particular neuron, biological neurons, have 4 sections. Our cell, this neuron is like a cell. Soma, or body of the cell, is a large round central body in which almost all logical function neurons are realized. If you see this small structure, this is called soma. Sorry. The axon. Now, as I told you, the neuron is a branch-like structure. In between, there is a sepule kind of a structure is there, which we call it the soma or cell body. And then the other fibrous structures are there. 2 kind of fibrous structures are there. One type of fibrous structure is called axon, another is called dendrites. So what is the difference between axon and dendrite? Axon, the task of axon is passing the signal to the next neuron. So the axon makes this is the interconnection point. The fibrous structure of one axon makes the connection between the dendrites of the other neuron. So they pass signal to each other. What is the role of dendrites? Dendrite is also a fibrous structure, but it receives the input. All right, let me repeat it again. Axon and dendrite both are fibrous structure. Axon is responsible to pass the signal to the another neuron, and the dendrite is responsible to receive the signal, right? Then synapse. This is very, very important in neural network, and how we will simulate this characteristics in neural network also. The synapse, when the axon and dendrites are interconnected at some point, the strength of that connection at a particular point is called synapse. Synapse are specialized contacts on a neuron which are termination point for the axon from other neuron. That's very, very important. So let's say the one neuron is passing the signal to the other neuron. So there are 2 chances. Like if we are pushing someone, if we push, there is a gentle push, the person may little bit shaken. If we have a heavy pushes there, probably there is a fumbleness will be there in a person. So that kind of a things we will establish an analogy. If the signal is passed from axon to particular dendrites of other neuron is having a strength, synapse strength is there, quite powerful, then the next neuron will be in excited state. It will get excited to pass the information to the next neuron. It will get activated. If the signal strength is low and not appropriate as per the threshold decided for a particular problem, then the next neuron is in inhibited state, sleeping state, inactive state. All right. So the synapse strength will decide that the signal passed from one neuron to other neuron is able to excite the other neuron or not. All right.
Ready?
Yeah. Okay, guys. So brain-like computers. We understand the biological neuron. We understand the constraint of the present machine. As we discussed that somehow we can say that human brain is also a computer. So can we develop a brain-like computer? That possibility we are going to study. And if it possible, then how it will happen? What kind of mathematical models are required? What kind of topologies are required? That we have to study in this topic basically. So here comes the concept of artificial neural network. As I told you that the neurons, biological neurons is a small computing element of our brain. So what we will do, we can develop a mathematical model for a particular neuron. But if we want to have a massive parallel structure, we want to have a associative memory also, we want to have the computing power also, then one neuron is not sufficient. There should be a multiple neurons. So different mathematical model of neurons will be there, and interconnection between those neurons will also be there. So as I told you, we are not going to model a human brain. What we are going to develop a model to solve a particular problem, to solve a particular task. So it is possible to simulate a mathematical model to solve a particular problem given, to find out the solution of that problem, and we can say that is how, and the biological inspiration has been used, right? So brain-like computer is a mathematical model of human brain principles of computation. This computer consists of those elements which can be called the biological neurons prototypes. When I say biological neurons prototype, clearly what does it mean? Mathematical model which are inspired from the biological neurons. So new paradigm of computing mathematics consists of the combination of such artificial neuron into some artificial neural network. So here we will develop learn the mathematical model of a particular neuron, and those mathematical model will have some interconnection, and in a particular topology, then that topology structure will called artificial neural network. We will see the formal definition also. All right, guys. ANN is a brain like computers. So artificial neural network is a massive parallel distributed processor that has a natural property for strong experimental knowledge and making it available for the use. Experimental knowledge. So what will be the role of artificial neural network? It will acquire the practical knowledge, and that knowledge will be available to solve the particular problem in a particular situation. Knowledge is acquired. This is a very, very strong statement. Knowledge is acquired. If you remember that, if you see that the small child is there in your house, how child learn from the environment, from the mother, parents, brother, sister, and outside also, sometime from the animals also. So that is the meaning of acquiring knowledge. When child grows, the child acquire the knowledge from the environment. Environment will be given by the parents, teacher, and anybody else. So here also we will do same thing with the neural network. The strength of interconnection between the neurons is implemented by means of synaptic weight used to store the knowledge. The interconnection between the synapse, the axon and dendrite will be decidable factor over here. The learning process is a process of adopting the weight with the learning algorithm in order to capture the knowledge. When I say acquire the knowledge and use that acquired knowledge to learn, to solve the new things, it means what? The strength of interconnection was there, everything in the format we just discussed that. So here the weights will be changed, and weight will be the learning process. How we will establish the learning process is a procedure of adopting the weights with a learning algorithm in order to capture the knowledge. One more mathematical aim of learning process is to map a given relation between the input to the output. What kind of input we are passing to the condition to solve the problem, and what expected output is there. So there is the structure, ANN will be able to map input to the output. All right, guys. So finally we comes on the concept of how our artificial neuron mathematical model will look like. The McCulloch was the first mathematician or scientist who gives the mathematical model of a simple neuron. So as I was discussing with you that neuron is nothing but, it is a small processing element. What kind of processing element? It takes multiple signals, and signal have some strength also, weight also. Let now establish the analogy between the strength to weight. Here now onwards we will call it a weight. The signal have a weight also. So signal will be treated as per the weight. X1, X2, X3 up to Xn are the signal parameters. W1 is weight of this signal X1, W2 is weight of X2, and Wn is the weight of Xn. So now these signals will be multiplied by their weights, and it will be summed over here. So in mathematically, neuron is nothing but it is summation unit. What kind of summation it is doing? It is doing summation of multiple of a particular input from that weight, and all the inputs corresponding to weights are summed. Then this will be the output of this particular neuron. Now, as I was telling you that when the signal is passed to the neuron, biological neuron, the only passing the signal does not guarantee that the signal will be in neuron will be in excited state or inhibited state. So what is the meaning of this H? It is activation function. It will decide that we will map the output in a particular range, so we can decide that it has a capacity to either exciting or inhibiting the other neuron. So neuron work for processing information. They receives and provide information in the form of spikes, signals. Neuron functionality is determined by the nature of its activation function. It's very, very important. So its main properties, its plasticity, flexibility, ability to approximate a function to be learned. That is very important. Ability to approximate a function to be learned. So this structure is a basic element of mathematical model of a neuron. And Mac-Pitts was the mathematician who first time gives this model. All right, guys. When we need a network, that's very, very important and relevant question. We have a computer, we have a different computing machines. Why we need a network? Why we cannot solve, or let's say we have a mathematical model of a neuron, why we cannot solve every problem by using a single neuron? So if you remember at the starting of the lecture, we were discussing about that. Massive parallel structure is there in human brain, right? High interconnections, high number of interconnections are there. Why these interconnections are there? Because human behavior, to simulate the human behavior is a difficult task. If we are developing a mathematical model, there is a quite chance are there we cannot solve all the problems via single neurons. That is why capability of more than one neurons are interconnected with each other and network is required. The functionality of a single neuron is limited. For example, the threshold neuron, the perception, cannot learn non-linear separable functions. If you will use a single neuron, you cannot solve this kind of problems. It cannot learn non-linear separable function. So what kind of solution is there? We have to do interconnection of more than one neuron. Ultimately, the need of artificial neural network arises, right? So this is the simplest kind of a network. You see, these are the inputs, neuron 1 and neuron 2. This is called input layer. Input layer has two neurons over here, neuron 1 and neuron 2. And see, if this input is having a connection over there also, the second neuron also. This input is also having a connection to the first neuron, second neurons. And the output of this neuron works as a input to the output layer neuron. So this is called input layer, this is called output layer. So this is the simplest structure of a neural network. I think it will give you the complete picture of neural. It is inspired by the biological neurons. Network, because more than one neurons are interconnected. Artificial, we are using mathematical model of neurons. So an artificial neural network is composed of many artificial neurons that are linked together according to the specific topology or structure. Let me give a brief about the topology also. Topology and structure depends on what kind of a problem we are solving. The objective of the neural network is to transform the input into the meaningful output. All right? So dear student, thank you very much. Let me summarize today's lecture. Today we will understand the background of neurons, biological inspiration of the mathematical model of neurons. We understand what kind of a critical behavior is there in human brain, and we try to understand that there is a possibility to design to simulate a complete human behavior on a particular machine in the form of machine. Then we learn the mathematical model of neurons given by the Mac-Pitts. And finally, we understand the definition of artificial neural network. In the next lecture, we will try to understand or try to how the neural networks are beneficial, what kind of attributes you have, and next lecture we'll discuss about it.